This is Post-Op Vitals Check, monitoring dogs after the use of anesthesia in surgery by Azariah Reid and Madison Norman.
We wanted to create a device that could effectively monitor dogs after the use of anesthesia while reducing the complications that come with it after surgery. We felt that the research we conducted helped us to find the most common things that hint at after-surgery complications, which helped us to figure out what we wanted to focus on in the creation of our project, which came to be temperature and heart rate.
Our problem statement is veterinarians need a way to monitor dogs after receiving a surgical procedure that requires anesthesia because a device to monitor vital signs for complications after surgery does not exist. The materials we used are Arduino Uno, infrared temperature probes, heart rate probes, a collar, fabric, zip ties, a 3D printer, portable battery, and USB cable.
We first conducted research, and my research questions centered around how anesthesia worked and the differences between them.
During my research, I mainly focused on the monitoring of sleep and the effects of uses of drugs in dogs.
Finally, we conducted research together to understand the common complications after surgery and the difference in monitoring cats and dogs after surgery.
For our hands-on discovery assignments, we focused on getting some background use with coding so we were familiar with the platforms. During the process, we used Arduino and Xcode.
We also conducted a visit to the Poolsville Veterinary Clinic, where we watched a live surgery, talked with the head veterinarian, Dr. Eeg, learned their protocol for administering the anesthesia, what happens during surgery, and monitoring after. As part of another discovery assignment, we completed interviews with Dr. Eeg, where that resulted in our visit, a Beltway surgical anesthesia technician, Azariah's mom, Mr. Walter, Dr. Turbush, and my dad. We received helpful information to advance the project in the future, such as specific numbers of the vitals that the dog should be after their surgery and also what causes alarm.
In the low fidelity period, we set out to create templates of what we wanted to create for our device. Below is a drawing and key of what we wanted to incorporate in the device. Additionally, in our low fidelity period, we created a physical 3D representation of what we wanted the device to ideally look like. We also created pseudocode, which explains what we wanted each part to be coded to do. This stage helped plan how we proceeded with the project. Next, in our mid-fidelity period, we set out to build a moderately working device. To start, we ordered all the parts and then got to work. Our first step was creating block code and building the physical exterior of the device. Towards the end of the stage, we ended up changing our coding platform to Arduino instead of microbit. This enabled us to get going on connecting all the different parts. In the image below, you can see us soldering the wires so our device would not short circuit.
As part of our high fidelity, Azariah created a 3D printed container for the Arduino and heart rate and temperature probes to be attached to the collar she created. I worked on the code with Mr. Dickey and Mr. Lum, and where we worked to combine the temperature and heart rate so that they will work simultaneously. After the completion of our low, mid, and high fidelity, we started to refine and retest our device. We wanted to create a better compartment for the Arduino board with its temperature and heart rate probes to create less of a hassle with the wires. Attached are the images of our before and after. We also wanted to find a different Arduino board to connect via Bluetooth, but given the events, we were unable to complete this step. Attached are our final results with Azariah's new 3D printed container and new attachments so that the container fits more securely. Also, we have finalized the code so that the temperature and heart rate finally run in a loop without any complications.
In our project, we focus on the effects on anesthesia on dogs and its post-operative complication. Our goal is to create a device that helps to monitor heart rate and temperature in dogs. Veterinarians need a way to monitor dogs after surgery to limit anesthesia-induced complication. During the project, we successfully created a device that displays the heart rate and temperature on the computer. Our code is designed to run both at the same time. Throughout the research, there was a lot of changing and downsizing, but we were able to produce a more clear and concise project. We did not get to test it on a dog because of issues surrounding COVID-19, but we know it works on humans. In the future, we have discussed adding alerts and getting a patent for our design.
So here we have what it would mimic looking like on a dog. So as you can see, this is the collar right here, and it just attaches it just easily with a clip. And so this is the heart rate, and this is the temperature, and it has an infrared sensor. And so this is what it would look like attached on the dog. So you have this one, and it's taking the electric pulses as an EKG would. And so the way this works, it takes what's around it. So if I put my hand over, you can see that the code over here goes up to 35 degrees Celsius, but if I take my hand off, which is off, it drops back to 26. And it's also taking the heart rate, which is around 136, but that's not the actual heart rate, it's just electric pulses that may be running.
We would like to thank all the Bullis staff, Dr. Eakin and his staff at the Poolesville Veterinary Clinic, and all of our interviewers for all of their help and guidance along the way. Thank you for coming to our presentation.